Hello everyone. Today we're doing 4H solutions of literal equations. So what we're learning about today is how to find solutions of equations that contain more than one variable. And what you need to be able to do is apply factorization rules to various polynomials and solve equations in terms of other variables. So before we begin, just a quick chat about what is a literal equation. Simply, a literal equation is an equation that has more than one unknown. So if you have, we're used to something being like x squared plus 2x, but the way to turn that into a literal is that instead of a 2, we would have an ax. Now, with literal equations, we're still solving for the variable x, but obviously we have unknowns now, which will make things a little bit trickier. When we're solving, the key thing to remember is that we try to factorize. If we can get it to the null factor law, then that's awesome because we can just use our brackets, x equals this, x equals that. There are other techniques, of course. So if you have a quadratic, you can always use the quadratic formula. Um, and if worst case comes to it, you can use your CAS calculator if you have access to the CAS. But in general, we'll be using these two techniques here today. So factorizing or the quadratic formula, and we'll be hopefully able to get to X from there. So it's really just a whole bunch of algebra. That's the key thing to this chapter. So we'll start with the first one. It says solve the following literal equation for X. Again, you can see that there's, an X term and there's also an A, but the A is just a constant. So I know it looks like a variable, but it's a constant. We can just kind of ignore it. It's just going to make things a little bit more trickier for us when we're solving. So the first thing I can recognize is that there's an X in every term. So I'm going to go ahead and factorize that X out. And that should hopefully make my life a little bit easier. Now, remember what we're trying to do. We're trying to get it into a form that we can solve so that if I factorize it, then I can use the null factor law. So I can recognize there's an x here. This is a quadratic term. So what I would love to do is be able to factorize that. Because it's a quadratic, you can absolutely use the quadratic formula, but you can do it a little bit easier as well. If you recognize this last term is 2a squared and this middle term is negative 3a. When we generally try to factorize a quadratic, we think of what are two numbers that will multiply to give me the last term and add to give me the middle term. So I can kind of see like to get 2a squared, one term would have to be 2a and the next term would need to be a. And this one, because it's a negative 3a, if I made both of these negative, when two negatives multiply, it will give me a positive, so that's great. But the negative 2a minus 3a actually ends up equaling negative 3a. So that's my two numbers there that I can use. So now I can go ahead and I can factorize by grouping, by splitting them up. So that's x squared. I can split this up, so that can be negative 2a minus a plus 2a squared. And then I can just factorize by grouping. So what's common in this first term? There's nothing really common here. So that'll just be x squared minus 2a. Here, sorry, I think I forgot to put an x in each of them. That's going to fix that up a little bit. So yeah, you need to put an x. So the 3ax becomes negative 2ax minus ax. So try that again. So now I can take the x out. I thought that was a bit funny before. X minus 2a. And then here I can take out an a. So we'll have x minus 2a. So it becomes a minus 2a because I already factorized the negative out, and two negatives multiply to give that positive there. Okay, now from there, I can take out the common term. So this will be our common term. So that'll be x minus 2a. And then these parts are the leftover. X minus a equals 0. Now we've got a beautiful form where we can factorize by the null factor law. So that'll be x equals 0, x equals 2a, and x is equal to 1a. So you can see it's a really nice way to be able to get to our answer, but there is quite a bit of recognition that happens here. All right, on to the next one. So part B, x times x squared minus a. Again, this is all about recognizing. So this looks like the difference of two squares. We know that the x squared is a perfect square, so that's all good. That can just, the first term will be x. Problem with the a is it's not a perfect square, but we can just write that as root a. So that will be the square root of that. So the formula we're using here is a squared minus b squared is equal to a minus b, a plus b. So a bit confusing if I say my a term is x and my b term is root a, but the idea is that the first term will be the square root of the first number and the second term will be the square root of the second number. So we can go ahead and factorize this way again. So this will be x minus root a and x plus root a. Now, this question really should have it equal 0 because we're trying to solve. So now that we've got it in factorized form, I can go ahead and use the null factor law. So that's x equals 0, x equals root a, and x equals negative root a. And that will be the solution to this one. Okay, next one here. So it says solve each of the following equations for x. So we have a times x plus b to the power of 4 is equal to c. Now, what I'm going to do is I'm going to go ahead and rearrange the equation. So in this case, you really can't do much more for factorizing. I can see inside is a linear factor, which is what we want x to be, and there's really not much more I can do. So all I can do here is rearrange. There's no factorizing that's required. It's already fully factorized. So to do that, I'm just basically going to get x by itself. I'm going to divide both sides by a. I will get c on a. Then I'll take the fourth root to the other side. And that does actually end up being a plus minus. So whenever you take an even root, it will always be plus minus. And finally, I will take the b over. So this will be the solution to x. The one thing that I would say, just to kind of keep in mind, you might be already thinking about it. Generally, it's not good to divide by an unknown because that unknown could equal to 0. But if a did equal to 0, then this whole thing would be 0, and then it just doesn't make any sense. So I try to avoid it unless it just will not make logical sense for it to be equal to 0. So in this case, it really doesn't, like a can't be is equal to 0 because this whole thing just doesn't work. So that's why in this case would be allowed to. All right, next one, it says, again, solve for x. Again, there's no factorization that's required. This is literally just going to be pure algebra. So again, I'm going to take the a over. We're assuming it's not equal to 0, otherwise the whole equation doesn't make sense. Now, when it's to the power of a third, the opposite is to put it to the power of 3, because a third times 3 is just 1, and whatever you do to one side, you do to the other, so that'll be x is equal to b cubed on a cubed. So you can see at this point, we're really just doing a bunch of algebra. All right, so that's it for this exercise. Please go ahead and try it out yourself.